Let's begin with the product rule. So what did the product rule say? It said if you took the derivative of the product of two functions, it wasn't just f prime times g prime, it was this whole thing, f prime times g plus fg prime. Now what I'm going to do is integrate both sides with respect to x. And this is going to give me my so-called integration by parts formula in a second. I have to manipulate it. But the basic idea is that if you integrate the derivative of the product, you just get the f times g on the left, and then on the right-hand side, I've gone and integrated with respect to x. So I'm going to take this, I'm going to rearrange everything, and the rearrangement has been that the integral of fg prime is equal to f times g minus the integral of fg prime, just a rearrangement of the previous formula. This is the integration by parts formula. It says if you have a product that's written in one way, in this case the integral of f times g prime, you can answer that as taking the product of f times g and a different integral, the integral of f prime times g. So it's sort of a way to take one integral, written as a product, and manipulate it into being a different integral that's also written as a product. By the way, there's another way to write this using u and v notation that's very, very common. Basically, the f and the u are the same, but the g prime dx is put together into a dv, and the f prime dx is put together into a du. But regardless, this is probably the most common way that integration by parts is written down. So let's see how we can use this particular formula in an actual example, the integral of x cosine of x. Basically what I have to do is when I see the x cosine of x, I have to say that there is a u in there and that there is a dv. I have to identify these two different parts. Well, which should it be? Should the x be the u? Should the cosine dx be the dv? Or should it be the other way around? Well, if I think about cosine, if I take its derivative or its integral, I can keep on doing that as many times as I want. It just keeps alternating between sines and cosines with minus signs. It doesn't really get any easier or simpler, it just sort of alternates. But for the x, if I take its derivative, the derivative of x goes down to 1, whereas the antiderivative of x is x squared over 2. So I want to take the derivative. I want to set the x equal to the u, and I want to set the cosine of x dx equal to my dv, because then I can take the du and the x is going to go down to a 1. So I've identified them here, the u and the dv, and actually what I typically do for myself, I find this helpful, is to actually go off on the side and write them down and be like u is equal to x and dv is cosine of x dx. And then I have to figure out that my du is just equal to, well, dx if the u is equal to x. And then if I know what my dv is the cosine dx, then the v is going to be sine dx, because the derivative of sine is cosine. So I sort of collect this data up here, and then I can go and fire it into the formula. So what happens when I do that? I'm going to have the x sine of x, that's my u times v, and then I subtract off the integral of sine of x dx. But notice what's happened. Now, integral of sine, I can do that. I know how to do that. That's an elementary one. And so I can compute that out, and I get x sine of x plus cosine of x plus the value of c, because this is an indefinite integral. Can't forget that plus c. So in effect, we transformed by integration by parts the integral of x cosine of x, which we did not know how to do, into the integral of 1 times sine of x, and 1 times sine of x we did know how to do, and so we did that integral.